What is the neurological basis for speech perception? Imagine trying to understand a friend's voice in a noisy room. Your brain works hard to pick out the sounds and turn them into words you understand. That's speech perception in action. When you hear speech, sound waves enter your ear and are turned into electrical signals by the auditory nerve. These signals travel to the primary auditory cortex, located in the superior temporal gyrus of your brain. This area is like a sound detective, analyzing features such as pitch and timing to identify speech sounds. Within the auditory cortex, a part called Heschl's gyrus plays a key role. It helps predict when sounds will happen, allowing your brain to follow the rhythm and flow of speech. This quick analysis is essential because speech sounds change rapidly, often over just a few milliseconds. Once the sounds are processed, your brain splits the work into two main paths. One path, called the ventral stream, is like a comprehension highway. It involves both sides of the brain and helps you recognize words and understand their meanings. Regions like the superior temporal sulcus and middle temporal gyrus are involved here. The other path, called the dorsal stream, is more active in the left side of your brain. It connects what you hear to how you might produce speech. This pathway links auditory areas to parts of the frontal lobe that control speech movements. It helps your brain match sounds to the motor actions needed to say words. The superior temporal gyrus and superior temporal sulcus are especially important for phonetic and phonological processing. They help identify basic speech units called phonemes and recognize patterns in speech sounds. Your brain's ability to process rapid sound changes is what makes understanding speech possible. Another key area is the planum temporale, which is involved in both understanding and producing speech. Stimulating Heschl's gyrus can temporarily disrupt speech perception, showing how vital it is. Similarly, stimulating the planum temporale can affect speech production, highlighting its specialized role. In summary, speech perception relies on early sound analysis in the auditory cortex, followed by two pathways that handle understanding and linking sounds to speech production. This system allows humans to decode complex spoken language quickly and accurately. From a linguistic point of view, understanding these brain mechanisms helps explain how phonetics, the study of speech sounds, relates to brain function. It shows how our brains process sounds to enable us to communicate effectively. Using the word perception in a sentence, speech perception depends on the brain's ability to analyze and interpret the acoustic signals of spoken language. This process involves multiple brain regions working together seamlessly. Knowing how the brain perceives speech is useful for developing better speech therapy techniques, improving language learning, and creating speech recognition technology that mimics human understanding.